Hello and welcome to MyScience Tutorials. In today's video, we are going to be looking at compound statements, biconditional, and contradiction. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. So we want to look at what compound statements are. Now, compound statements are statements using two or more logic operations. Now, in the previous tutorials, we look at what the logic operations are. We have the conjunction, which is the AND operation. We have the disjunction, which is the OR operation. And then we have the implication, which is another operational science we look at. Now, creating the truth table is a systematic way of determining when a compound statement is true and when it is false. Let's look at an example to further understand what we mean by compound statement. Now, example number 1. Construct the truth table for the following. Now, we can see that in this compound statement A, we have the implication sign, which is one of the logic operations. We have the AND operation, which is the conjunction operation, and then we have another implication. So we can see we have three logic operations over here. We have the implications, two of them, and then we have the conjunction operation also here. So let's look at the truth table for example A. Alright, so we have two statements. We have P and Q, so we write our P and then our Q here. So we have here P implies Q, so we need to write that two down. P implies Q. We also have what? Q implies P, which is the converse of this. So Q implies P. Now we have the entire condition, which is what? P implies Q and Q implies P. Okay, so let's go ahead and see the truth table for this. Now, for the statement B, we have true, true, false, false. For Q, we have true, false, true, false. Now, we can now go ahead and use these two truth values to find the other operations that we have, or logic operations. Now, P implies Q. Let's look at that. Now, P implies Q, as I said in the previous tutorial, can only be false if the starting condition is true and then the ending is false. So it means for the first part over here, true, true is a true statement. True, false is a false statement because it's an implication, and it is only false when the starting operation is true and then the ending is false. So true, false is false for an implication. Now, false, true is true, and then false, false is also true for implication. Now, we are looking at what? Q implies P, now which is now the reverse. So true, true is a true statement. False, true is a true statement. Now, true, false. Remember, Q comes first, so we are using Q first. So true, false is what? A false statement. Then we have what? False, false, which is also what? A true statement. Now we are going to use the AND operation, or the AND logic operation, on these two to have our final answer. So we have true and true is a true statement. False and true is a false statement. True and false is also a false statement, and then true and true is a true statement. Now remember, the logic operation conjunction, or the AND, is only false. Okay, it's only false when one of the truth values is false, and it is true when both are true. So we have here true, true, so it means it is a true statement. We have true, true, it is a true statement. But once we have one of them to be false, either here or here, the final answer, or the final truth value, is false. So this is for the A aspect of this question, which is what? P implies Q and Q implies P. Now, let's look at the second aspect of this question. So B, So the B is what? The negation of what? P or Q implies Q and P. So let's go ahead and see the truth table for this. So we have P, we have Q. We can see that we have what? P or Q over here. Then we have the negation of that, negation of what? P or Q. Okay. Then we have this, which is what? Q and P. Then we have the final one, which will combine all of them. My table is not up to, so let me create another one here. So the final one is what? The negation of P or Q implying Q and P. So let's go ahead. So we know for any statement P, we have true, true. Sorry, this is true, true, false, false. So for Q, we have true, false, true, false. Okay. So for P or Q, it means either both should be true or one of them should be true to make this column true. Okay. So it means here we have true, true. So it's a true statement for or the disjunction. So we have true, false, it is true because one of them is true. We have false, true, one of them is true, so it is true here. We have false, false, it is false. Okay, so the negation of this statement is what we have over here. Now if we negate true, it becomes false. So we negate this true again, it becomes false. We negate this true, it becomes false. We negate the false, it becomes what? True. So let's go ahead. Now we come to what? Q and P. Q and P. Now let's go. This is our Q and P. So we have what? True, true, true Q, true P is a true statement. Now the Q again, we have false, and then what? This is true. So it is what? A false statement, because both of them has to be true to make the end or the conjunction to be true. Now this is what? True, this is false. So it is a false statement. Now false and false is also a false statement for conjunction. Now we now have the final answer, which, or the final true values, which we are going to write over here between what? The negation of what? P or Q implying what? Q and P. So it means we are looking at these two tables here and here. So this implies this, this implies this. So let's go ahead and see that. So we have false implies true. This is a true statement. False implies false is a true statement. False implies false is a true statement. And then we have true implying false. This is a false statement. I said how come true implying false is a false statement in the previous tutorials. Or for implication, the only way the implication will be false is when the starting material or the hypothesis is true, but then the conclusion is false. So if the hypothesis, which is the one starting, is true, but then the conclusion is false, it becomes what? A false statement. Else the true value for any other condition is true. So let's go ahead. Biconditional. So what is a biconditional? Given two statements P and Q, the conjunction, that is what? P implies Q and Q implies P, of implication P implies Q and its converse Q implies P, is called the biconditional of P and Q, and is denoted by the symbol P, the double implication sign Q. So what we mean by the bicondition is if we have a statement or an implication statement that is P implies Q, and we do the conjunction between this statement and its converse will now be what? The reverse of this, which is what? Q implies P. Now this becomes what? The biconditional of the compound statement. Or we can just simply say P implies Q, and then what? Q also implies P. So this is the biconditional as we are talking about. Now, P biconditional Q can also be stated as P if and only if Q, or P is equivalent to Q. Now let's look at the truth table for the biconditional. So we have the statement P, we have the statement Q, and then we have P biconditional Q. So we have the values over here. So we have true, true, false, false, as we normally write for any first statement. And then the second statement, we have Q. Then we have the true values to be what? True, false, just to make it balance. Now, for biconditional, if P is true and Q is true, it is a true statement, or both of them has to be the same for the resultant to be what? To be true. If one of them is false, then the resultant will be false. What do I mean by this? Let's look at this. True is what? True. And this true is also this true. So the statement is a true statement. True is false, but false is not true. I take it again. Truth is false, but false is not true. So the biconditional is what? Is false over here. False is not true, and true is not false. So this is also a false statement. Now false is false, and then false is false. So this is true. So now do we see that when we have true is true, it means this true is also this true, this true is also this true. So it is a true statement. We have false is false. False biconditional, false is what? A true statement, because false is false and false is false. Now once one of them is different, it becomes what? A false statement. Alright, so let's move on. Now we need to note something. A compound statement M is called tautology if the true value of M is true for any assigned values of the statement occurring in M. So what do I mean by this? So it means whenever we have tautology as a compound statement, it means the resultant or the truth value for the resultant are all true statements. You will not see any false in there. So let's look at an example. Example number 1. Show that the following compound statements are tautology. We have what? P or negation of P. We have I. Negation of P or Q implies P. So let's go ahead and solve the first one. I, which is what? P or negation of P. So we have P. We have negation of P in the table. Then we have the two of them as the compound statement over here. So we have P or negation of P. So for P we have what? True, true. Sorry, this is true, true. False, false. So negation of P will not be what? Negation of true will be false. Negation of true is false. Negation of false is true. And this is also true. So the operation P or negation of P means one of them has to be true to make the truth table of P or negation of P to be true. So we have true, false over here, and because it is what? Disjunction or the or operation, it is a true statement. So we have true, false is a true statement because one of them is true. We have false, true, and then it is true because one of them is true. We have false, true, and it is true. Now can we see that the truth value for P or negation of P are all true? Yes, because they are all true, we can vividly confirm that P or negation of P is tautology. Alright, now let's see whether the negation of P or Q implies P is also tautology. So the I aspect, which is what? Negation of P implies, negation of P or Q implies P. Alright, so we have our P, our Q statement. We can see negation of P over here, so we should have negation of P. Then we can see what? Q implies P here, so we write Q implies P. Then we write the final one between all of them, which is what? The negation of P or Q implies P. So we have P to be true, true, false, false. By now we are used to this. And then our Q statement will be what? True, false, true, false. Now the negation of P will be what? The inverse of this. So true statement will become false, true statement will become false, false statement will become true, false statement will become what? True. Alright, now Q implies P. Q implies P, meaning Q implying this P. So true is true. We have false true is what? True. Now true false is false. Like I said, when the hypothesis is true and then the conclusion is false, it is a false statement for implication. Alright, so we have the Q again, which is false, and then it means this is what? True as well. Alright, so now let's see. We have negation of P, or Q implies P. Now we are using the operation what? Or between the two of them. So which means, let me use another color to indicate that we are using the operation what? Or between the two of them, which means if one of them is true, it is enough to make what? The truth table of this side to be true. So we have false here, what? Or true. Because one of them is true, this is true. We have false here, we have true here, so this is what? True, because we are using or the disjunction. Now true false, this is a true statement, true is a true statement. Now can we see that the overall truth value or the truth table for negation of P or Q implies P are all true? Yes, because they are all true, we can also say that what? This is also what? Tautology, as said by the question over here. So assuming you draw the true value for these two, which the question is vividly telling you are all tautology, and you had one of them to be false, it means somewhere in the process of finding the true value you made a mistake. So you need to go back and cross-check all your implication or the disjunction or the conjunction to make sure you have just true, all values here to be true for it to be tautology. Alright, let's move on. Contradiction. Okay, so what is a contradiction? Now, a compound statement is called contradiction if the true value of M is false for any assignment of the true values of the statement. So it means the contradiction is the opposite of the tautology. So whilst in the case of the tautology where we have all this to be true and all this to be true, for contradiction we are going to have this, all of these values to be false, and then all of these values to be false. Now let's look at an example and see if that is actually what? True. Okay, so example number 1, show that the following compound statements are contradiction: I, P, and negation of P. So we are dealing with the I, which is what? P, and negation of P. So I have my P statement, the negation of what? The P, then P and negation of what? P. So my P is what? True, false, false. Negation of P will be the inverse of everything over here. So it is what? False, true. Now, because we are using what? The conjunction, which is and, it means both of the operations or both of the statement has to be true for the true value over here to be true. Once one of them is false, it makes it a false statement. So I have true false. Because one of them is false, it is also a false statement. I have true false over here, it's a false statement. False true is a false statement. False true is a false statement. Now can we see that all the true value for P and negation of P are all false? Yes. Because they are all false, we can say what? P and negation of P is a contradiction and not tautology. So this indeed is a contradiction. Now let's look at the second one. So the I have what? P and Q, and Q implying negation of what? P. Alright, so I have P, I have Q, I can see negation of P here, so I have negation of P. I can see what? P and Q over here, so I have P and Q. I can see what? Negation of, Q implying negation of P over here. Then I can see the final overall statement, which is what? P and Q, and what? Q implying negation of what? P. All right, so let's go ahead and see what we have for this. So I have the P statement to be what? True, true, false, false. I have the Q to be what? True, false, true, false. Now negation of P is the inverse of everything we have over here. So we have what? This will become what? False. This will also become false. This will become what? True. This will also become what? True. So let's go ahead. Now P and Q. P and Q. So we are using this as our first value and then this as our second statement of value. So P and Q. So we have true, true is a true statement. Now we have true, false. Because one of them is false, this is a false statement. False, true. Because one of them is false and we are using what? And or conjunction. This is what? False. So we have false, false is also what? A false statement. All right. Q implies negation of P. So we are using Q now implying what? The negation of P, what we have over here. So true implies false. Okay, true implying false over here, we are going to get what? A false statement. Like I said, when the hypothesis is true and then the conclusion is false, it is a false statement. Now I have false, false. False, false is what? A true statement for implication. True, true is a true statement for implication. And then what? False, true is what? A true statement. Okay, so we can see that the only way for it to be false is when what? The hypothesis or the one starting the implication sign is true, but then the conclusion or the ending is false. That is when we have a false statement. Now I can see the conjunction between P and Q and then Q and negation of P, which is what we have over here, the conjunction or the end between them. So we can see that we have true, false over here. This is what? A false statement, because we are using what? Let me use another color to indicate that red. We are using what? The conjunction or the end operation. End operation. So because we are using the end operation, this is what? True, this is false. So because one of them is false, this is false. Let me continue with the same colors. All right, so we have false, true. This is what? A false statement, because one of them is false. I have false, true is false. I have what? False and true. This is what? False. So we can see that the conjunction between what? P and Q, and then Q implies negation of P, are all false statements. Therefore this statement is also what? A contradiction. Contradiction. All right, so thank you so much for watching, and then I'll see you in the next video. Bye bye.